All right, let's see how we go about filling in a truth table. I put up two statements here, neither A nor B. That says not the case that either A or B, and this says not A and not B. They both have two statements in them, A and B, so they're going to get 4 lines to make their truth table. The way to do that is you begin with the left-hand letter, and since you know it's going to be 4 lines long, you give it two trues and then 2 falses. And then you half that for the next one and make it true, false, true, false. If there had been a third letter, we'll look at that in just a minute, then you would have had to have 8 lines, and you'd have had 4 trues in the first case and 4 falses, then 2 trues, 2 falses, 2 trues, 2 falses, and then true, false, 2 true, false. Having filled in these values as the guide values, this shows all the possibilities for that statement. We can now calculate the wedge between these values, and then finally we can calculate the tilde acting upon the wedge. So true or true gives a true, true or false gives a true, false or true gives a true, false or false gives a false, because we know that a wedge or an either or is only false if both parts of it are false. And now this tilde reverses the value. So not true is going to be false, not true is going to be false, not true is going to be false, and not false is going to be true. So these are the values for this statement, line by line. Let's look at this statement over here. Again, this one said neither A nor B. This one says not A and not B. Again, there's 4 lines to get to, because there's 2 letters, A and B, so true, and false, and true, false, under the letters themselves. Now here the tilde operates upon the letter both times, so here we're going to write F, F, T, T, and here we're going to write F, T, F, T. And now the dot is going to be the operator that joins these values. False and false is a false statement, false and true is a false statement, true and false is a false statement, true and true is a true statement. So these are the values that we get for the dot in that statement. Notice, if you look at them, there's 2 things we can say here. One, this is what's called a contingent statement, because sometimes it's true and sometimes it's false. FFFT. On some lines it's true, on some lines it's false. So that's called a contingent statement. And this one's also a contingent statement. Sometimes it's true and sometimes it's false. But it's interesting that this statement and this statement both say the same thing: false on line 1, false on line 2, false on line 3, and true on line 4. So they're absolutely equivalent to each other. Because from one line to the next they say exactly the same thing. And that's what this truth table for each of them shows, is not only that they are contingent statements themselves, but that they are equivalent to one another. Now let's erase that and put up a truth table for a larger statement. This will be a statement that has 3 letters in it. And I'm just going to go with something very simple like A implies C and D, because we're just trying to make sure we get the basics of building truth tables straight here. This has 3 letters. That means it's going to take 2 times 2 times 2 lines, which is 8. So we're going to make true, 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 4 trues, and then 4 falses in order to get 8 lines. And then we're going to have 2 trues and 2 falses under the C, and then 2 trues and 2 falses again. So you see, here's 4 and 4, then here's 2 and 2, 2 and 2, and now we're going to half that again to 1 and 1, TF, 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 TF. So that's the principle that you always use. You start at the left-hand side with the greatest number of trues, and the greatest number is going to be half the number of the total lines the table calls for. And a 3-sentence table is going to be an 8-line table. A 4-sentence table would be a 16-line table. On a 16-line table, you'd have 8 trues and then 8 falses. Then 4 and 4 and 4 and 4, and then 2 and 2, 2 and 2, 2 and 2, 2 and 2, so forth. Same principle now. Start with the smallest unit and calculate true and true is true, true and false is false, false and true is false, false and false is false, true and true is true, false, false, false. And now you can now you apply the rule for the horseshoe, which is that a horseshoe is true unless the antecedent is true and the consequent is false. So this one's going to be true because it's true implies true. True implies false, that's false. True implies false, that's false. True implies false, that's false. Now, the rest of them, the antecedent is false each time. So without even looking over at the consequent, I know right away it's going to be true, 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 true. Because a horseshoe is defined as saying it's true unless the antecedent is true and the consequent is false. And that's not going to be the case if the consequent is an F the whole way down. There you can see the bottom of the chart better.